Okay, so environmentalists concerned about the impact of high-frequency radio transmissions on birds found that there was no evidence of a higher mortality rate among hatchlings in nests near cell towers. So random. They based this conclusion on a test using an alpha of 0.05. Would they have made the same decision at alpha of 0.10, and how about at 0.01? Explain. So, we know that there was no evidence. So basically, not enough evidence. So what does that mean? Are we rejecting or are we failing to reject? Yep, so we fail to reject because there is not enough evidence. So we fail to reject the null. We don't really have to even know what it is because, or let's see, and the alpha is 0.05. So this means that since there was no evidence, we failed to reject. That means that the p-value was greater than 0.05. Now, they don't tell us what the p-value is. So as far as their question, would they have made the same decision at an alpha equal to 0.1? So we don't know.
Okay.
So basically, yeah. So at an alpha of 0.1, either decision is possible. So basically, it could have been greater than 0.1 where we would still fail to reject, or it could be less than 0.1. We just know it has to be greater than 0.05. So it could be anywhere in there. So either decision is possible. All we know is that the p-value is greater than 0.05. So then they say, how about an alpha of 0.01? So what do we know about that then? If the p-value's, huh?
Then we don't know. Or
Well, so if the p-value is greater than 0.05, what has to be true at 0.01?
that it's wait, it's p-value is greater than that.
Yeah, so it has to also be greater than 0.01 because 0.01 is less than 0.05. So the same decision. I'm just going to put fail to reject. The p-value is greater than 0.01. And I could do this because 0.05 is greater than 0.01, just for the visual.
Cass says Same thing.
Just leaving off a letter here and there, minor details. All right, so have harsher penalties and ad campaigns increased seatbelt use among drivers and passengers? Observations of commuter traffic failed to find evidence of a significant change compared to 3 years ago. Explain what the study's p-value of 0.17 means in this context. So we want to know if the harsher penalties and ad campaigns have increased seatbelt use. And it also says observations of commuter traffic failed to find evidence of significant change compared to 3 years ago. So I would start with the null with this one to explain what we're looking at. So the null hypothesis would be that seatbelt use is the same as 3 years ago, because our null is always that there's no change. The alternate is that seatbelt use has changed, or more specifically increased, because that's what it says in here. So that would be if they gave us numbers, P would be greater than whatever that value is, since it's increasing. But they told us they failed to find evidence, so there is not enough evidence, so they failed to reject. So they failed to reject the null, meaning the p-value is not too low. So then the way we would kind of explain in the context of this problem what this really means, basically assuming seatbelt use is the same as 3 years ago, we would see sample results as extreme or more extreme about 17% of the time due to sampling variability. Just realized the next question also goes on to the next page. All right, so a report on healthcare in the United States said that 28% of Americans have experienced times when they haven't been able to afford medical care. A news organization randomly sampled 801 Black Americans, of whom 38% reported that there had been times in the last year when they had not been able to afford medical care. Does this indicate that this problem is more severe among Black Americans? Test an appropriate hypothesis and state your conclusion in the context of the problem. Assume all conditions have been met. So, I see 28%, so that's going to be our P. I also notice that it says the problem is more severe, so I want to make note of that. So my null hypothesis would be that there's no change, so P is equal to 0.28. And so if it says it's more severe, is that less than, not equal to, or greater than? Yep, so P is greater than 0.28. So at this point, I would use one prop z-test, and this is for, let's see, stat test, one prop z-test is option 5, so the null is 0.28, so this is 0.28, then x is, let's do this over here. X equals 0.38 times 801, because it's 38% of the 801 is our X value. 0.38 times 801. And that produces a decimal of X equals 304.38, but in here I've got to just put 304. N then is the 801. And then we select greater than, calculate. So we get P hat is 0.37 Oh wait, I don't really need p hat, but I just wrote it anyways. Z, which if we did Z scores, it would do this way, is 6.27. But the actual p-value that I'm looking for is 1.77 times 10 to the negative 10. So what is that approximately?
0.
Yeah. So this is approximately 0. So that means I would reject the null hypothesis. So there is enough evidence. Hold on, I want to make sure this isn't going in another question and I'm doing this all together. Okay, yeah, it goes here. So there is enough evidence to suggest essentially the problem of affordable health care is more severe now. Something along those lines. Doesn't have to be perfect. Basically looking for the key stuff of I reject the null, there is enough evidence, and that's pretty much the key things. The way you word the other part doesn't make not as big of a deal. So then specifically explaining what this means in context, which is part B, assuming 28% have difficulty accessing health care, we would see a sample with 38% having difficulty or more extreme. About 0% of the time. Due to sampling variation. Now, obviously, this particular sample was 38%, or was it 38%? Yeah. And that's the p-hat value there, the 38%. But in theory, I should really not ever see that again, according to the statistical analysis of this, because the Z value is 6.2, which is essentially that's how many standard deviations away we are. So that's extraordinarily unusual. So was your test left tail, right tail, or two tail? Yep, right tail, because the rate had increased. Or it said, I guess, technically more severe, I think is how they worded it. Okay. A local newspaper in a large city wants to assess support for the construction of a highway bypass around the central business district to reduce downtown traffic. They survey a random sample of 1,152 city residents and find that 542 of them support the bypass. Construct a 95% confidence interval to estimate the proportion of residents who support the construction bypass. So this is essentially just a confidence interval. So just as a refresher, confidence interval is the statistic plus or minus the critical value times the standard deviation of the statistic. Or we can just use one prop z interval. And that will be for 542, unit circle down, 1,152, and it says 0.95. So that would be stat test the wrong way. One prop z interval for 542, 1152, 0.95. So this gives me 0.442 to 0.499. So based on the confidence interval, test the null hypothesis that city residents prefer to keep the business district as it is. So basically, we're going to say that essentially it probably should be like a 50-50, that there's like no change. So the null hypothesis would be residents do not want to bypass, which would be something like P equals 0.5. I guess I could say 0.50. The alternate would be residents do want to bypass. I don't know why I did residents. It's like residents. And so if they do want to bypass, that would mean I need more than 50% of them. So P would be greater than 0.50. So what do we notice if we need more than 50%? Like, what does our confidence interval tell us? Yeah, if we round it, it's going to 50%, but we need more than 50%. So I'm going to fail to reject the null hypothesis because based on the confidence interval, less than 50% of the population want a bypass. So then what is the significance level for this? Well, what type of a test is this? Left, right, or two? Yeah, so it's a right tail. So if I look at a visual like curve of this, and we're looking for 95%, that's in here. But I only want this side over here. So that means I've got 5% left over, but how much is on the right side? Yeah, so basically we've got, whoa, not that. 2.5% is over here and 2.5% is over here. Whoa, not that. So alpha is equal to 0.025. So that would be the significance level for this one, for this specific situation. So that's how we do it if they've given us a confidence interval, like where they say like we want a 95% confidence interval. All right, let's see, just to try to get this one more thing in here before the bell. So a type 1 error, just kind of as a refresher, because we briefly talked about it the other day, is a false positive, which means the null is true, but we reject. A type 2 is a false negative, which means the null is false, but we fail to reject. Gonna see if I can do this really fast. Testing for Alzheimer's disease can be a long and expensive process consisting of lengthy tests and medical diagnosis. Recently, a group of researchers devised a 7-minute test to serve as a quick screen for the disease for use in the general population of senior citizens. A patient who tested positive would then go for the more expensive battery of tests and medical diagnosis. The authors reported a false positive rate of 4% and a false negative rate of 8%. So the null hypothesis for this would be patient does not have Alzheimer's. I'm just going to say disease because spelling that word, I spell it wrong every time. The alternate would be that the patient does have it. I'm going to try to do these because it's easier to see with an example. So I'm going to try to do these two really fast if you don't care.
Okay.
All right, so a type 1 error in this situation is that the patient does not have the disease, but their test says they do. They get a second opinion. And find out they are okay. So that would be the 4% that's a false positive. The type 2 would be that the patient has the disease, but the test says they don't. So they miss the chance to be treated. So this is the 8%. So which one do you think is worse? But like which situation, not the like percentages. Do you think it would be worse to be told you have it and then find out you're okay, or not be told you have it and then you don't get treated? Yeah, the second one. So type 2 would be worse. They think they're healthy.
Oh wait. It's Tuesday.
But they are not.
I gotta
Yes.
go downstairs. Never mind.